So in this video, I'm going to show you how the PCB looks like and some of the things you need to know about PCB and just try to understand different parts of the PCB. If you're used to using breadboards and wires, this is a good experience, a learning experience for you, so you can understand how a breadboard and wires translate to your PCB, which is eventually what you want to do in the end anyways. So let's take a look. So first of all, this is a PCB, this is a rigid PCB right here. This is actually a rigid flex, so there's a flex portion as well, but let's ignore this for now. Let's talk about the PCB itself. As you can see, this is green color. That's because there's a green color solder mass applied, so everywhere there's a coating, we call it solder mass, and usually it's green color. That's why most of the PCBs are green. But you can also have blue, red, black, white, or clear color, yellow, pink, purple, whatever you want. Green is the most common because under the green you can see these traces or lines that you see. They are made of copper, so they have copper colors. And green is the best when it comes to versus copper. Green versus copper has the best contrast ratios. So when you want to inspect the board, green is the best color. Okay, now these are traces. We call them lines as well, lines or traces. Imagine you have a hole here and you want to connect it to this pin on a breadboard. That will be your wire, but over here it's a trace. Okay, and it's made of copper under this green color, so it has specific properties. You need to learn to calculate your traces. Like you have to have a minimum width right here. You can see this is the width over here, so you need to have a minimum width because that width will determine on how much current is passing through. So you need to calculate that width to have minimum width, which will guarantee your amount of current that's passing through and the resistance. Anyways, let's take a look. So on a PCB you got these traces. You got traces, you have holes right here. Now you can see some of the holes are blocked, some are open. That's because there are different types of holes. They're plated through hole, they're non-plated hole, and within plated through hole you also have vias versus component hole. Vias are basically, these are all vias. What that means is these holes are connecting these pads or traces to the pads or traces on the other side, on the bottom side of PCB, or if this is a multi-layer board, then they may be connecting multiple layers as well. So they are called vias, meaning they're not, you don't have any leads going through, component leads going through them. They're just used for connecting different traces to between different layers. So these are called vias. Then you have a couple of mounted connectors. These are SMT connectors. Maybe resistors or something. So yeah, they are SMT mounted. I will show you in a second. Okay, let's take a look here. This is a chip, and it has leads on each side. Again, this is surface mount technology, meaning these leads are not going through a hole. These are just pads, surface mount pads, because and the leads this chip is just sitting on top of the PCB, and that's why the reason you design a PCB instead of using breadboard is so you can take advantage of using on both sides. So SMT, because it's SMT surface mount, that means this design is only on this side. When I flip the board on the other side, you can utilize this as space for something else. If this was through hole technology, then you cannot, because then you have a hole going through the board, and then on the other side you cannot use anything else because the hole will take away the space, right? Okay, here's a fiducial. What is a fiducial? Fiducial is basically a copper pad, and there's no copper around, so this is a copper clearance. Fiducial is basically a copper pad separated from the rest of the design. It's just an independent pad, and it's golden color because it has a surface finish applied to it. In this case, it's gold. And the reason you have fiducial pads is, in most cases, a chip like this, when you use machines to mount this chip, the machines needs a reference point for alignment. So this is called fiducial, which is basically an independent copper pad which is here for alignment purposes, and the machine will use this pad and go X and Y to be able to align these pins right here, these leads or pins, to this specific XY location. That's why you have a fiducial. Then you can see this little area right here. This is copper. Okay, this is again under solar mass, but they're probably for various reasons, for heat dissipation or whatever, they may put the copper area. So that's copper. This right here, white color, is siltstream, which is an epoxy ink applied on top of this green color solar mass. And the reason is basically marking the location of where the component should go. This little thing right here, this dot here is this dot is basically identifying pin 1 here. So when you look at the data sheet, you usually have a little dot on a data sheet on pins, which basically identifies pin 1 or pin 0 or whatever. So that's the whole point of this dot in siltstream, because it's identifying the pin as per the data sheet. Now I rotated the PCB by 90 degrees, and I'm looking on the other side of the flex part. And as you can see, these holes, these are plated through holes. That means first of all, they all have surface finish applied to them, so it's gold. But under the gold is copper, and these holes are component holes, meaning some kind of connector lead will go through these holes and you will solder them. Either solder them on this side or on the other side of PCB. This is a flex area because this PCB is bendable, so I can bend it like this, right? So this is a rigid flex, not pure rigid, but rigid flex, so I can bend it. And this is a flex area. It's a special material. The flex layers run in the middle of your rigid flex. But I don't want to talk too much about flex side. I just want to talk about the rigid in this video. This is on the other side. You can see how these leads are mounted. So this SMT chip is right here. You got these leads, and they are soldered on, but these are not hand soldering. These leads are done by SMT machines, but they're so small it's hard to solder by hand, and it's not that efficient either. So this, you can see, is basically solder, which you can see here, and the solder pad runs like this. Okay, and these are sitting on that solder pad and soldered. And here's the flex part. You can see on this side the traces. There are traces running, so these are basically carrying some kind of signal between the two board. And as I said, again, this is a rigid flex, so it's part of the board. Okay, it's not a cable or anything, it's part of the board. Here I'm showing you a different board, but this board is not finished, so that's why there's no solder mask over here. It was scrapped during the production, so that's why. So, but you can see all of this is actually copper. Because it's not finished, there's no surface finish applied to it. That's why there's no solder mask, there's no gold or any other surface finish. It's just pure copper. So this is how design looks like under the solder mask. As you can see, let me point it. This area, there's no copper. It's just laminate, like FR4 material right here. Okay, and this is all copper. And these holes are supposed to be vias. Okay, these are all via holes. And these are non-plated holes. There's no plating, so these holes are probably used for mounting, right? Mounting this PCB on something. Sorry, this is non-plated. This is plated. You can see the copper around it, so this is plated hole. This is why you need to understand DFM, which is designed for manufacturing rules, because when it comes to manufacturing, you have to worry about a lot of things. Like, for example, the minimum line width that can be manufactured. So the minimum width of this line right here, the spacing between the two lines, spacing between the pads, spacing between the lines, spacing between this is a copper pad around the via, and it's also called annular ring. So anytime you have a copper pad around a hole, whether it's a whether it's a plated hole, as a component hole or as a via, it's referred the round pad around it is referred to as annular ring. meaning how much copper left on each side of the hole. So that's called annular ring. So you also have to, when it comes to DFM, you have to think about what's the annular ring, because there are certain rules needs to be met. Also, the difference between copper pad to copper pad, minimum copper pad to copper pad, minimum distance between edge of the hole to edge of the hole, and this is on the other side. This this copper is on the other side of this board, on the bottom side, and you can see the distance between two copper plane. You need to understand what is the minimum distance required. That needs to be calculated. The minimum distance that you can work with between the edge of a non-plated hole and a trace or edge of a non-plated hole and a copper clearance around it, edge of the hole, non-plated hole to the copper pad, edge of the copper pad, distance between surface mount pad to surface mount pad, distance between edge of the trace to edge of a copper pad, distance between edge of the trace to edge of a hole. So these are some of the things you need to consider when you're designing your circuit board, and there are many more rules.